Hello, Tom from Every Step Physics, EveryStepCalculus.com again. The vertical spring given mass, the spring constant, and the speed or velocity. This is a test problem, probably a homework problem, and entered by a student. So let me show you how my programs do this. You can purchase my programs at www.everystepphysics.com for $30, and you get 350 of my step-by-step programs that you download into your titanium calculator with all instructions. You get my help in physics if you call me or email me, and you're on your way to passing physics, homework and tests. And of course you'll have this for the rest of your life in your titanium if you don't sell the calculator. Now, and this is like searching for something in Google versus going to the library, or something, I don't teach physics or calculus, I just show, and which is really what we're interested in, showing how to do the problem. But in physics you're supposed to memorize about 300 formulas and be able to pull them up in 2 seconds. Look for all the tricks that professors love to give you, which is the conversions of variables that they give you, and trying to understand the problems, as they don't really help when they put it on the physics board, Physics books authors and physics teachers are all trying to show everybody how smart they are, and they can never come down to our level, which is dumb as a student, and our questions are necessary and they'll never answer them. You can't answer it in a book or anything, but my programs go through all that, okay, and I help you tremendously in physics. Let's do it. Physics, to get to my menu. Main menu. I'm already at springs to save time. We scroll down there, we press enter. Spring calculation, we choose vertical because it's vertical in the problem. Press enter, and then we're going to choose what's given, and the variables is mass, k, which is the spring constant, and then velocity, which is the speed that they give you. This is during the motion of oscillation that the spring goes through when you put a mass on there and pull it down and let it start to oscillate. So let's scroll down here to mass and k. There's k, there's amplitudes, other things depending on what they give you. Here's velocity, v, okay? We're going to choose that, and we're going to enter our variables, okay? You have to press alpha first before you enter anything in these entry lines here. Alpha, the mass is given at alpha .711. Okay, that's given in kilograms, so no conversion is necessary. And we're going to enter the spring constant, 136. Alpha 136. And that's Newton meters. Notice they might give you foot pounds, they might give you kilonewtons per meter, which is 1,000 Newton per meter, and I do those conversions for you. Here's millimeters and centimeters. I've seen that in tests, and then I program it that way. Aren't you lucky? Press enter, and we're going to put in the initial velocity, which is alpha .302. And that's meters per second, number 4. You can press the number here on your calculator, or you can scroll down to it. I'm just going to press number 4, and that If it's not given, you choose the first one. This changes the sign of the velocity for other problems like collisions and things like that in my programs. So I always show you what you've entered, and you can change it if you want. I say it's okay, and we start the calculations. First, we find the angular frequency, square root of k over m, constant over the mass, 13.83 rads per second. I'm adamant about showing you when you put a letter down here what it equals, which is period. Professors don't do that, of course. They just start with 2 pi w, and then you never know what they're talking about. So here's period, 2 pi over the omega here, which is the angular frequency, 0.4543. And big deal in springs is that the potential energy that a spring has when you compute that, which is 1/2 k times the amplitude squared, is equal to the kinetic energy, which is 1/2 mass times velocity squared. Okay, that's the big deal. Conservation of energy. Excuse me for trying to teach just for a second. And we come up with these calculations. We're trying to find amplitude here. Press enter. So we have a squared equals 0.032. As we do the calculations of this, we come up with this right here. And of course, amplitude is going to equal the square root of that, equals 0.02184. Now try this on a test, okay, from memory. If you think you're so smart, you know, I mean, you study it for weeks. You could study springs, but there's so much more to study in physics, you know. Acceleration is the amplitude times the omega squared, 4.1768 meters per second squared. The stretch is how much the mass pulls down on the vertical spring when you attach it to the end of it because of gravity. And that has to do with Hooke's law. Excuse me for teaching. And turns out to be 0.5129 meters. And potential energy is figured here, 0.03242. You never know what they're going to ask you, so I put down, you know, a lot of that stuff. You can see the answers again by pressing 1. Go through the answers again. I'm going to go through quickly. And then we press 2 to go to another problem if you want, okay? Pretty neat, huh? EveryStepPhysics.com. Go to my site, buy my programs, and pass physics. Have a good one.